Very good morning, friends. Today's subject of discussion is protection of carboxylic acids. How we can protect the carboxylic acids from undergoing the reactions. And later on, after carrying out the other reactions, how we can deprotect it. Let us look into it. Generally, the carboxylic acids are protected in the form of esters. Esters are formed by many methods. The esters are generally alkyl esters. One of the foremost method of preparation of alkyl esters is Fischer's esterification. It involves the reaction of the carboxylic acid with alcohol in the presence of an aqueous acid like concentrated HCl or H2SO4 and so on and so forth. The lone pair of electrons on the oxygen of ROH attacks on the carbonyl carbon owing to its deficiency of electron, which is attributed to the electronegative oxygen to which the carbonyl carbon has attached. As this OH is electron rich and is electron deficient, unlike poles attract each other, the electrons are shared with the carbonyl carbon, and OH being an easy living group in the presence of an acid which gets protonated and it leaves as water molecule, and thus we can get the required alkyl esters. Another method of preparation of alkyl esters is converting this acid to acid chloride. Many of the times OH is not very easy living group. That's why to make it easy living group, we add concentrated HCl or H2SO4 or any other mineral acids. Many of the times when the reaction won't work out, then we convert into acid chloride and then treat with alcohol. And preparation of benzyl esters or aromatic esters are accomplished by this method. I take RCOOH, treat with a chlorinating agent like thionyl chloride or POCl3. Even PCl5 and PCl3 can also be used for this purpose, where the OH in RCOH gets replaced by RCO's chlorine and gives rise to acid chloride. This acid chloride which is formed reacts with alcohol. The lone pair of electrons on the alcohol attacks on the carbonyl carbon, and chlorine is an easy living group. That's why it gets kicked off and it combines with H plus to give rise to corresponding HCl. This gives rise to an ester, the aromatic ester. Tertiary butyl esters can be prepared by treating the acids with isobutylene and an acid. Methyl esters is also an alkyl ester. It can be prepared by treating the carboxylic acid with diazomethane. Though Fischer esterification is a general method, even the alkyl esters can be prepared by treating the acids with isobutylene, and methyl esters can be prepared by treating with diazomethane. These are the other methods of preparation of alkyl and aryl esters. All the esters, either aryl or alkyl esters, can be cleaved under basic conditions, that are mild basic conditions preferably. A mild base like lithium hydroxide in the presence of THF or water can be carried out depending upon the ester solubility, and the hydrolysis of the esters can also be accomplished by using various enzymes which are more eco-friendly. The tertiary butyl esters can be cleaved with aqueous acids as These tertiary butyl esters are stable in basic conditions. This can also be cleaved by using dibutyl tin oxide, benzene, and reflexed to hydrolyze. These are the various methods of deprotection of the formed alkyl esters, which are of acidic, alkyl or aromatic in nature. We can also prepare 9-fluoronyl methyl esters by treating the acid with fluorinyl alcohol. Fluorinyl alcohol and acid, they react together to form an ester in the presence of a dehydrating agent like dicyclohexyl carbodiamide, which is called as DCC. The lone pair of electrons on the oxygen attacks on the carbonyl carbon and OH gets kicked off. H plus and OH minus loses water molecule in the presence of a dehydrating agent like DCC to give the corresponding 9-fluorinyl methyl esters. Overall, there are four methods of protecting the esters. The alkyl esters generally protected by using the protected reagent by like alcohol in the presence of sulfuric acid, or it can be converted into acid chloride and then treated with alcohol in the presence of a base. The salient features that lies in the preparation of alkyl esters and aryl ester is the ease of formation and a facile cleavage. They are cleaved by using a mild base like lithium hydroxide in the presence of THF and water as the solvent. This can also be accomplished by enzymatic hydrolysis by using various hydrolytic enzymes and by reduction. Methyl esters can be prepared by treating with diazomethane in the presence of methanol and acid. These methyl esters are stable towards oxidation and Lewis acids along with borane and other catalytic hydrogenation conditions. Hence, they are cleaved by using the mild base like lithium hydroxide and the mineral acids like HCl and H2SO4. The deprotection can also be accomplished by reducing agent, mild reducing agent like sodium borohydride in ethanol. Tertiary butyl esters can be prepared by using the protecting reagent like isobutylene and acid. And these tertiary butyl esters can be cleaved under mildly acidic conditions via an elimination reaction. The other alkyl and methyl esters are stable to acidic condition, but here they are stable to basic condition. That's why we are using aqueous acids like dilute HCl and H2SO for the deprotection purpose. Continuing with that, the benzyl esters can be prepared by converting into benzyl alcohol, benzyl by treating with benzyl alcohol as the protecting reagent, and it can be converted into acid chloride and then react with benzyl alcohol. This benzyl esters deprotection can be accomplished by using palladium and carbon, a reducing agent in the presence of hydrogen. These benzyl esters are stable towards neutral condition. Hence, we go for reductive cleavage. 9-fluorinyl methyl esters can be prepared by treating the acid with fluorinyl methyl alcohol as the protecting reagent. These fluorinyl esters can be deprotected by using a mild base like piperidine in the presence of DMF. These 9-fluorinyl methyl esters have can be removed selectively under mild basic conditions, and they are stable under acidic conditions like trifluoroacetic acid. These are the methods of protecting the carboxylic acids. There are four methods, and next presentation we can deal with the protection of other functional groups. Till then, have a nice day. Thank you.